Welcome to part 2 of lesson 5.3, Factoring Trinomials. By the end of this lesson, you'll be able to factor trinomials algebraically. The first thing we're going to look at with factoring trinomials is factoring trinomials of the form where they have an ax squared term, a bx term, and a c term, or a constant term. And we're first going to look at examples when a is equal to 1, but the steps here on this page tell us the steps for whether a is 1 or not. So let's look at this important point here, the star. You could factor a trinomial of the form ax squared plus bx plus c by replacing the middle term, bx, with two terms whose integer coefficients have a sum of b, whatever number b was, and a product of a times c. And remember, a product is when you multiply. So whatever a times c is equal to, we want our two integers that we're looking for to equal the same number. This process is called factoring over the integers, and we're going to have lots of examples of that, if that sounds a little bit scary. Step 1, if we look at it here, is to find the two integers that multiply to a times c and add to b. And we take those two integers and we're going to rewrite the trinomials so that there are 4 terms instead of 3. The middle term, bx, that we used to have is going to be changed so that you have the sum of two x terms with the integers that we just found. So we're going to take those two integers and we're going to put them in our trinomial. Then with our 4-term polynomial that we just made, we'll be factoring it by grouping. And that we learned in lesson 5.2, so we'll have a review of those steps. Okay, let's look at our first example of factoring a trinomial of the form ax squared plus bx plus c where a is equal to 1. We notice that there's no number written in front of the x squared, so we would have, it's like having a 1 there. That would be your a value. A is going to be equal to 1. Your c value is the constant at the end, so c is equal to 4, and your b value is the number in front of the x term, so b is equal to positive 5 in this example. Step 1 from the previous slide was to find two numbers that multiply to whatever a times c is. So 1 times 4 is still just 4, so we need to find two numbers that multiply to 4, and they have to add to 5. So I like to make a list of those numbers that multiply to 4, and then we'll find out which ones add to 5. Multiples of 4 would be 1 times 4, and 1 plus 4 is 5. So this one actually works right off the bat. Let's keep going though. Other multiples of 4 would be 2 times 2. 2 times 2 would add to 4, so that would not be an example that would work. We want to use 1 and 4 because it adds to the right number. So then we look at rewriting our polynomial so that we have 4 terms. The first term stays the same. It stays as x squared. And then we're going to rewrite the 5x, the middle term, as the sum of two terms with the integers we just found. So plus 4x plus just 1x, or x. And then plus 4 stays the same. Alright, so again, we rewrote the term 5x, the middle term of the trinomial, as the sum of two x terms with the integers that we found that multiply to 4 and add to 5. Okay, so now what we do with those integers is or this polynomial, is we are going to factor it by grouping. So if you recall from lesson 5.2, we make two groups. So put your brackets around the first two terms is your first group, and around the last two terms for your second group. And then what we do is we're going to factor each group separately. So we look at the first group and we say, okay, what greatest common factor can we take out of that? Well, both terms share an x in common as a factor. So we're going to divide both terms by x. And then we're going to rewrite our greatest common factor out front, and whatever's left over in brackets. So x squared divided by x is x, and 4x divided by x is just plus 4. And now we're going to do the same thing to the other group. we take a greatest common factor out of it. Well, this one's a little bit interesting because neither term shares an x, like the plus 4 does not have an x as a common factor, and the x term here just has a 1 in front. So when we are dividing out a greatest common factor, we have to divide by something. The only thing we can divide by is 1. So we're going to do that. We write our plus 1 here on the next step, and the leftovers in brackets is actually just the same thing, because anything divided by 1 is the same. Alright, one more step here. Now we have a new polynomial, and it actually has two terms. So our first term is x times x plus 4, and our second term is 1 times x plus 4. In these two terms, there is a common factor, okay, and the common factor is x plus 4. That's where you have a binomial as a common factor. So we're going to divide that common factor out. Okay, your common factor comes out front, and whatever's left over goes in brackets after the common factor. So when you have x times x plus 4 divided by x plus 4, the x plus 4's cancel out to 1, and any number divided by itself equals 1, and only thing left over is x. So we write x, and similarly in the other term, the x plus 4's would just equal 1, so we're left with plus 1. And the factored form is x plus 4 times x plus 1. What do you notice about those numbers in the answer? So we have a plus 4 and a plus 1. Well, if you look back to the numbers that we had that multiplied to 4 and added to 5, they're the same integers. Okay, so this is kind of a long way of doing this question, and there's a bit of a shortcut. If the a in the original polynomial is equal to 1, so you just have x squared plus something x plus something, then you find the two numbers that multiply to the last number, c, and add to 5, and those two integers can be subbed directly into your answer if you write it in the form of two factors with x first, and then you fill in your two integers. So we had a positive 1 and we had a positive 4, and then you can just leave that as your answer. Remember, order of multiplication doesn't matter, so you can write the x plus 1 factor first, or you can write the x plus 4 factor first, like we did in the first method. Okay? Alright, so to summarize what we just did on the previous slide, using some steps, what you want to do is, if you see that a is equal to 1 in the trinomial, the first step is to find two integers that multiplies to c and adds to b. Step 2, use those two integers from step 1 to write the factors in this form: x plus one of the integers and times x plus the other integer. We're going to do several examples now using this method. The first one is to factor, well actually this would be the second example using this method, factor x squared plus 7x plus 10. We need to find two numbers that multiplies to 10 and adds to 7. Numbers that multiply to 10 are 1 and 10, which would add up to 11, so we can't use those two numbers. And 2 and 5 multiply to 10 and add to 7. So 2 and 5 are the integers we want to use. So the factored form of x squared plus 7x plus 10 is x plus 2 and x plus 5. In example 3, we're going to factor x squared minus 7x plus 10. We need two numbers that multiply to positive 10 and add to negative 7. So we start looking at factors of 10. 1 and 10 multiplies to 10, but 1 plus 10 adds to 11. Well, because we need to add to a negative number, let's try some negative factors. Negative 1 times negative 10 also would multiply to positive 10, because negative times negative equals positive. and negative 1 plus negative 10 would equal negative 11. So that's closer to negative 7. So let's try negative 2 and negative 5. Negative 2 times negative 5 equals positive 10, but negative 2 plus negative 5 is equal to negative 7. So those are the two integers that we want to use, and we can write our factored answer here as x with one of the integers, so minus 2, and x with the other integer, so minus 5. Notice how we keep the signs that were with the integers, positive or negative, in our factors. In example 4, let's factor x squared plus 4x plus 6. We need two numbers that multiply to 6 and add to positive 4. So numbers that multiply to 6 are 1 and 6, 2 and 3 for the positive options. 1 plus 6 is 7, 2 plus 3 is actually 5. So far we have no sums that are possible. We can try the negatives as well, but they aren't going to work either. So what does that mean? Well, it means that there's no possible combinations of factors that can add to 4, so this polynomial cannot be factored over the integers. If we're going to factor this polynomial, we'd have to use other means, such as the quadratic equation. Example 5 is factoring the trinomial x squared minus 29x plus 28, if possible. And what we do here, again, is find two numbers that multiply to 28 and add to negative 29. So numbers that multiply to 28 could be 1 and 28, 2 and 14, etc. 1 plus 28 is positive 29. So let's just look at these two numbers. If we need to add to a negative number, let's try negative 1 and negative 28 as our factors. They would add to negative 29, and then we have the one we need. They're the two integers that we need. So we can rewrite our answer, or write our answer, as x minus 1 times x minus 28. Alright, example 6. We have x squared plus 3xy minus 18y squared. This, even though we have an x and a y in this equation, we still can factor this with our methods that we've been using. Just means that our answer, the factors will need x and a y in each factor. So I'm just going to go ahead and list the multiples of negative 18 that possibly could add to positive 3. Because we need to multiply to a negative number, one of our factors has to be negative and one has to be positive. So we could have positive 1, negative 18, which would add to 1 plus negative 18 would equal negative 17. So that's not right. Let's look at negative 2 and positive 9, maybe. Negative 2 plus 9 would equal positive 7, so we're getting closer. Negative 3 times 6 would also equal negative 18, and negative 3 plus 6 would equal positive 3. So those are the two numbers we want to use. And we just go ahead and we set up our two factors, same as we always did. The first part of each factor has to have an x in it, okay, just like before. And then we use our integers with y's as the second part of them. So minus 3y and plus 6y. Here we have our last example, 2r squared minus 14rs plus 24s squared. We look for a greatest common factor if we can divide out of every term first, and we can divide by 2. After we divide out the 2, we're left with r squared minus 7rs plus 12s squared. We want to find two numbers that multiply to 12 and add to negative 7. Looking through our list of factors here, we see that negative 3 and negative 4 work to add to negative 7. So we write our final factors as 2 times r minus 3s times r minus 4s.